Welcome to the session on forces and motions, force diagrams. The objectives for this session are to draw force diagrams and find resultant forces, and understand and apply Newton's first law. A diagram which shows all the forces acting on an object is called a force diagram. Each force is represented by an arrow pointing in the direction in which the force is acting. Problems involving forces are modelled by force diagrams. Let's take a look at an example. A cuboid of weight W is pulled to the left by a force P. Draw a force diagram showing all the forces acting on the cuboid. So here's our cuboid. Here's the weight. Here's the normal reaction of the rough horizontal plane on the block. And here's the pulling force P on the block. And finally, the resistance due to friction between the block and the plane. When forces which act upon an object are balanced, it is said that the object is in equilibrium. An object at rest will remain at rest, and an object moving with constant velocity will continue moving with constant velocity. Unless an unbalanced force acts upon it. So Newton's first law of motion states an object at rest will remain at rest, and an object moving with constant velocity will continue moving with constant velocity unless an unbalanced force acts on it. Constant velocity, of course, is that neither the speed nor the direction changes. When more than one force acts on an object, resolve in a particular direction to obtain the resultant force in that direction. The direction in which the forces are resolved is the positive direction. An arrow next to the letter R will indicate the direction in which the forces are resolved. So the horizontal direction could be an R with an arrow pointing right or an R with an arrow pointing left. And similarly in the vertical direction, we could have the letter R with an arrow pointing up or an R with an arrow pointing down, as shown. A resultant force which acts on an object causes the object to accelerate in the same direction as the resultant force. Let's take a look at an example. The forces acting on a particle are shown in the diagram below. The resultant force acting upwards is 15N minus 10N. Here's 15N, and 10N, which is acting in the opposite direction, is taken away from it to give us 5N. And in the horizontal direction, R is equal to 8N minus 8N, the force which is acting in the opposite direction, which gives us 0N. So the net effect, or the resultant force, is acting upwards, 5N. So the particle is accelerating in the upwards direction. This brings us to the end of this session. If you have understood its contents, you should be able to draw force diagrams and find resultant forces, and understand and apply Newton's first law. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.